Have you ever felt like time is just slipping away, one second after another, like a steady, predictable drumbeat? But what if I told you that this constant flow is just an illusion, a local phenomenon? Out there, in the vastness of space, time gets weird. It stretches, it shrinks, it slows down. This isn't science fiction. It's the mind-bending reality of our universe. We all experience time as a steady progression. The clock on the wall ticks at the same rate as the one on your wrist. But according to the laws of physics, time is surprisingly flexible. Imagine it's not a rigid ruler but a stretchy, rubbery fabric. Where you are and how fast you're moving determines how much that fabric stretches or compresses. Your personal experience of time can actually be different from someone else's. So, who figured all this out? The one and only Albert Einstein. Over a century ago, he completely revolutionized our understanding of the cosmos. He showed us that time and space aren't separate things. They're woven together into a single, four-dimensional fabric called space-time. And here's the kicker. Your journey through this fabric is a trade-off. The faster you move through space, the slower you move through time. And it's not just speed. Gravity, the force that keeps us pinned to the Earth, literally bends and warps this space-time fabric. And where space-time is bent, time itself slows down. Let's look at a real-world example. The astronauts living on the International Space Station, whipping around our planet at an incredible 17,500 miles per hour. That extreme speed has a measurable effect. Because they are moving so much faster than us down here on the surface, their clocks are ticking just a tiny bit slower. It's an effect known as time dilation. When they return to Earth after a 6-month mission, they are a few milliseconds younger than they would have been if they had stayed home. They have literally time traveled into our future, even if just by a fraction of a second. But it's not just speed that plays with time, gravity does too. Einstein's theory also predicts that the stronger the gravitational field, the slower time will pass. So, time actually runs slightly slower for someone living at sea level than for someone on top of a mountain, because they are closer to the center of Earth's mass. This might sound insignificant, but it has huge practical consequences. The GPS satellites orbiting high above Earth are in a weaker gravitational field, so their internal clocks tick faster than ours on the ground. If engineers didn't constantly correct for this difference, your GPS navigation would be off by several miles every single day. Now, let's take this to an extreme. Imagine you're near a black hole, an object with gravity so immense that nothing, not even light, can escape. Here, the warping of space-time is so severe that time slows to a crawl. If you were watching a spaceship fall towards a black hole from a safe distance, you would see it slow down as it approached the edge, the event horizon, seemingly frozen in time forever. But for the astronaut inside that ship, time would feel completely normal. They would feel themselves cross the event horizon in an instant. The mind-bending part, both perspectives are correct. This all leads to a staggering conclusion. There is no single, universal clock ticking for the entire cosmos. Your personal timeline is unique to you. Your now is not the same as the now for someone on Mars or in a distant galaxy. Every object in the universe, from you to a planet to a particle of dust, is on its own unique journey through space-time, with its own clock ticking at its own rate dictated by its speed and the gravity it experiences. So, does this mean we can travel through time? Well, in a way, yes. We're all time traveling into the future at a rate of 1 second per second. But by harnessing the principles of relativity, you could travel into the future faster. If you could build a spaceship that travels close to the speed of light, you could go on a journey for what feels like a year to you, only to return to Earth and find that centuries had passed. You would have effectively jumped into the future. Traveling back in time, however, is a whole different ballgame. It's a concept that opens up a Pandora's box of paradoxes and, for now, remains firmly in the realm of theory. You might think this is all just abstract physics, but the reality of time dilation embedded in our modern world It's not just about GPS. It's crucial for deep space exploration, for communicating with satellites, and for particle accelerators where scientists smash atoms together at near light speeds. Our entire understanding of reality, from the tiniest particles to the largest structures in the cosmos, depends on accepting that time is not what it seems. So, the next time you look at a clock, remember this: time isn't just a simple, steady flow. It's a dynamic, responsive property of the universe itself. It responds to motion, it bends to gravity. Here on our little planet, it gives us the comfort of a steady rhythm. But out in the grand theater of the cosmos, time reveals its true, wild, and wonderful nature. Thanks for watching, and if you want to keep exploring the mysteries of the universe, make sure to subscribe.